Okay, grade 11's the last video in this section on analytical geometry, and now we're going to be looking at perpendicular lines. Right, the first thing I'm going to tell you is a line is perpendicular if the gradient of one line times, or two lines are perpendicular if the gradient of the one line multiplied by the gradient of the second line are equal to -1. We know that those lines are perpendicular. Right, so we have our Cartesian plane and we have two lines that we're going to prove whether these lines are perpendicular or not. Perpendicular means that they have 90 degrees right angle at intersection. Right, let me get rid of these. Okay. Given the points A, B, C, and D, prove that AD is perpendicular to BC, right? So we have our points A, B, C, and D, given that AB is equal to CD. Right, so what is the gradient of Y is equal to, we first got to calculate the gradient. We know the gradient formula, y2 minus y1 over x2 minus x1. Right, so let's have a look at these gradients. Firstly, let's look at this side of the equation. -5 minus 4, right? So -5 minus 4, this is BC. So this is the line BC. Minus, and then 9 minus -6. We're going to multiply that with this side of the equation. So that is now AD. So we went -4 minus 11, -3 minus 6. And we need that to equal to -1. And need that to equal -1. So what we did here, we picked our y2s and our x1, our y1, our x1, our y2, our x1. And now we've got to prove that these two are equal. So, because these equal to -1, we can see that AD is perpendicular to BC. Right, so this turns into a left-hand side is equal to right-hand side. So, what do we have on the left-hand side? -5 minus 4 is -9, right? What is 9 minus -6? That's +6. 9 plus 6 is equal to 15. Multiplied with -4 minus 11, that is equal to -15. And -3 minus 6 is equal to -9. Those go to positive, and then we have still a negative left. Those cancel out, those cancel out. We are left with -1. So hence the left-hand side is equal to the right-hand side of -1. Right-hand side. And that is a perpendicular line, or two perpendicular lines. Okay, calculate the gradient of a perpendicular line. We're given the points A, B, C, and D, and AD is perpendicular to BC. Determine the gradient of DA. So we know that the gradient is y2 minus y1 over x2 minus x1. So the gradient of BC is equal to -5, that's our y2, minus 4, 9, minus -6, right? And that is equal to -9 over 12, which is -3 over 4. That's the gradient. So we know that the gradient of AB needs to equal -1, right? So the gradient of AD, if we know it is perpendicular, has got to be MAD, so the gradient of this line here, multiplied by the gradient BC, which is -3 over 4, and that's got to equal -1. So we can quite easily see that MAD is equal to 4 over 3, right? And also, we simply take the inverse. That's exactly what we have done. So how can we find the missing coordinates? We have our line, our perpendicular line, with our gradients. We have with our coordinates. We have our missing coordinate x. So we're given these points. Determine the value of x. And we're told that they're perpendicular. Remember, that square box means it's perpendicular. It's always useful to draw the lines connecting the points because you can already see if they are maybe perpendicular or not. So you've got to always do that. Not that this should ever be a proof enough. You always got to do both, but drawing always helps before you calculate it. So we have the gradient GE, right, times the gradient DF is equal to -1. We know that. Okay, so let's plug this all in play. Okay, so we know the gradient of GE is equal to -6 minus 6. That's over here. Then we know it's 6 minus 3. Then we know that this gradient is negative 4 minus 5. And then lastly, negative 2 minus x, and I've subscripted it d because it's on the d point. Okay, those are x1s, are x2s. So we have negative 12 over 9 multiplied by negative 9, and now over negative 2 minus xd. Right, so how can we move on from here? We simply see that those cancel out to give us a negative. That negative becomes positive. So we have 12 over negative 2 minus xd. We can simply move that to that side, times it all by negative 1 to get 12 equals 2 minus x. X is equal to 10. That easy. Okay, let's prove that a triangle is right angle. This is our last example for perpendicular lines. We have the triangle XYZ, which consists of the following 3 points. Right, we've given the coordinates of the points. Using the 3 points, prove that triangle XYZ is right angled. How do we prove something is right angled? Right, what does that mean? What do we have to do? We have to find that m of either zx times m of either xy is equal to negative 1. But this could be true for m of zx times m of zy is equal to negative 1. Or it could be m of xy multiplied by m of zy is equal to negative 1. So there's quite a few possibilities. Let's take these 2 points. mx, this is why it's useful to draw. You might be able to spot that that doesn't look right angle, that doesn't look like a right angle, but that does. Save your time. Let's get our m of zx. So we put this as our x2, 2 minus 5, 5 minus minus 2, and we get mxz, zx is equal to negative 3 over 7. Then let's have a look at mzy. These are 2's. Negative 9 minus 5, negative 8 minus minus 2. That's easy. We're going to get negative 14 over 6. Now, let's check if these are equal to negative 1. So we got our left-hand side, right? Left-hand side says negative 3 over 7 times negative 14. So this can go negative 3 over 7 multiplied by negative 7 over 3. Those cancel out. Those cancel out. Oh, there's a negative there. Apologies. Those go into positive. So that's going to equal negative 1. We can see that the triangle XYZ is right angled. Well done, grade 11s. That is perpendicular lines. What you got to remember, sort of the opposite of parallel lines. M1 times M2 equals negative 1 for 2 lines to be perpendicular. Well done.